Hello everyone, and welcome to the 41st episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi. Thank you very much for joining today. And on this episode of TechLifeSkills, we're going to get to hear from a very special guest that I have been incredibly excited to talk to for many weeks now. Now, he is a leader in the field of artificial intelligence and machine learning technology. And as you may already know, AI happens to be one of my favorite areas of tech, albeit what I also think is one of the most misunderstood areas of technologies as well. Now, as a matter of fact, a couple of months ago, when the hype for OpenAI's new GPT-3 was in full swing, is actually when I found our special guest today. Now, he was particularly outspoken on the limitations and sort of like the grounded perception that we should have when it comes to this kind of technology. And so that message really resonated to me, and I thought, you know what, it would be great to be able to discuss this kind of technology with him in more detail and share his message with all of you as well. Now, his name is Gary Marcus, and actually, as I was preparing this intro today and sort of to tell you a little bit more about what Gary does, I had asked him, how long he's been working with the sort of AI umbrella of technologies, and his response was that there is no simple answer to that question in his case. And so you know what, I would love to go ahead and now learn more from Gary himself. And so without any further ado, let's welcome Gary to the show. Hi Gary, how are you?
Hi, thanks for having me. So to answer your first question that you asked me off camera, I've been interested in AI and technology since I was 8 years old. But the first AI tech that I worked with was a paper computer, which simulated basically machine language. And I had a whole round of doing AI as a child, leading to me going to college when I was just a little bit younger than you are now. I wrote a Latin translator in the programming language Logo, which is basically Lisp. And that allowed me to skip the last couple of years of high school. So that was my first run at AI. Wow. And then I spent the next few decades, we don't have to do the math here, mostly looking at human children and trying to understand how they learn. Because the conclusion I came to when I was about 16 was that AI was way beyond what we could do with the technology that we had at that time. And that we should understand something about how human beings do natural intelligence. And so I've spent a lot of my career looking at natural intelligence. I got a PhD at MIT working under Steven Pinker, looking at how children learn language. And that led me to also study neural networks, which were kind of in, let's say, their second incarnation of popularity. They were popular in the 50s. They were popular in the 80s. That popularity faded both of those times. We'll see if it fades again. And now they're in their third phase. And then I lost interest in AI. I got, really into what I was doing. I was looking at neuroscience and molecular biology as well as psychology, which is maybe my first discipline. But I'm really a cognitive scientist doing all these things. And then in 2012, actually, because of Watson, I got interested in AI again. So I had got myself a little gig writing about AI and cognitive science for the New Yorker, which is a very fun gig. And when Watson won at Jeopardy, I thought, and I don't often think this, I thought, hey, I'm wrong about something. That's interesting, because I'm always looking to see what I don't know. And I didn't think that an AI system could win a natural language focused game like Jeopardy. Now, it turns out, in my view, that it won kind of because of a cheat, a sort of accidental cheat, which is that 95% of the answers to Jeopardy questions are titles of Wikipedia pages. And so that means that what you can do is basically you can search the titles of the Wikipedia pages and find the best fit with kind of information processing techniques. There was some real language in there, but at the inferential level, it was not that powerful a system. So it's sort of one, I would say, for the wrong reasons, which is often true in AI. Something succeeds because there's a lot of data, not because there's real intelligence there. But that got me interested in AI again in 2012. I remember it pretty distinctly. And a couple of years later, DeepMind sold to Google for $600 something million. And I said to some friends, what they had here is basically some good ideas and some good people. We could do that. It's not like they're selling widgets for 90 cents a piece to a billion people, which at that time didn't really appeal to me. But they're building ideas, and there was value in these ideas. So instead of writing about them for the New Yorker, maybe I should start a company. And so I recruited Zubin Garamani, who I'd gone to grad school with, who's one of the world's best machine learning people. He's now at Google, but at that time he was a free agent, and we started this company called Geometric Intelligence, and that's when I started really building AI stuff for the first time. So Zubin and I came up with an idea. We filed a patent, and we built a company around that, which Uber eventually bought just 2 years into our existence. And since then, I've been trying to build AI and not just, I guess, write about it. Most recently, I launched a company last year called Robust AI. And what we're trying to do is to make robots smarter. And part of that comes from my critique of AI. So, I'm probably best known as a critic of AI. And it's not that I don't think that AI is possible. I think AI is totally possible. I'm not someone who thinks there's some, evanescent, ethereal thing that is consciousness that we will never replicate, and therefore we can't have AI. We can talk about consciousness. I don't think we need it for AI. We can certainly build intelligent machines in very narrow domains. We've done it. So, AlphaGo is intelligent about Go. It's just, it doesn't know a lot else. So my view has always been that we can build AI, but that we're doing it the wrong way. And the reason we're doing it the wrong way, I think, is twofold. One is we often focus on these narrow problems that can be at some level brute forced. We could talk about what I mean by brute force versus a classical definition, but you can solve them with immense amounts of data without a lot of subtlety, understanding the domain. AlphaFold is not like that. There's some subtlety in the domain there. But in general, there are problems like that, and Deep Blue back at IBM. And then there are problems where we don't really care if we get a right answer. We're happy with the statistical approximation. And those are problems like advertisement recommendation or newsfeed recommendation, which I think has actually had terrible consequences for the world. But take advertisement recommendation. If I recommend an ad to you and I can do it 30% of the time, as opposed to no percent of the time, that's fantastic. But it doesn't necessarily, from a commercial perspective, but it doesn't necessarily mean that you have any underlying understanding. You could just count up and you say people who, bought this also bought that, and you have no idea why they did it. They just happen to have bought both. Or you can have book recommendation system. I say you might like my book, or you bought my book, Rebooting AI, and recently recommended to somebody who bought it, Barack Obama's new book. Now, I don't know, there are a lot of people that would like my book and not his book, but if that should turn out to be the case, then somebody wasted $30. It's not the end of the world, or they can give the book to their friends. So you don't need a lot of high precision in recommendation. But you do in something like driverless cars, right? You can't be 90% accurate. You can't be 99% accurate. You can't even be 99.9999% accurate. You have to do a little bit better than that. And robotics, and driverless cars actually are robots. Robotics is a place that pushes us to build artificial intelligence that actually works, that really understands the world around it and can make decisions around what that world is like. And the more so if you move from, let's say, a robot following a white line on a factory floor, which really doesn't need to understand that much as long as the white line on the floor is in the right place. If you move from that, let's say, ultimately to something like Rosie the Robot, if you're old enough to get the reference, which is an all-purpose domestic robot that was in, a 1965 television show. If you were going to get to that, or C-3PO or something like that, a humanoid robot that can do a lot of different things, it really needs to be reliable and not stupid. And so imagine, a robot the size of and weight of C-3PO that doesn't understand that knocking over candlesticks can set fires, right? That would be bad, right? It's kind of okay that Roomba is not too bright, but even there are problems, right? Roomba famously occasionally gets into there's actually a word for it now, the poopocalypse. Where Roomba will spread dog waste around somebody's house and it looks like a Jackson Pollock painting. So, even Roomba could use to be a little bit smarter. But now you imagine, a domestic robot, or let's say a robot in a nursing home. It can't, be knocking everything over. It's got to really understand what's going on. And so I decided that robotics was a place to keep AI honest. I don't think ad recommendation keeps AI honest. I think it leads to a certain kind of research, which is about pulling out certain kinds of statistical regularities, but it doesn't lead to research that takes us to AI that understands the world around it and can reason about it. So where you enter my story, so to speak, is you read this piece about GPT-3, and I had written an earlier one about GPT-2. And what I'd said in the earlier one about GPT-2 is this is the wrong avenue for AI. It's very cute. You can make up stories with it, kind of surrealist fiction. And for a few lines, they're cute. They're not going to make sense at a novel length, but for a few lines, they're very cute. But I said, it's not really understanding the world around it. And so sometimes it will work because statistically what it's doing is basically predicting the next word in the sentence. It's doing that very well. Sometimes the next word in the sentence is actually what you want. Sometimes it isn't. And so I gave some examples there. Like one of them was, if you drink a bottle full of Clorox, what will happen to you? Or bleach or whatever it was. And, the system was like, you get a stomach ache. And no, that's not really good medical advice. You really don't want to drink a whole bottle of bleach, right? And GPT didn't understand that. It didn't have kind of physical understanding. So then GPT-3 came along. And I should say, at the end of I wrote two things actually about GPT-2. At the end of one of them, an article called The Next Decade in AI, I said, getting more data is not really going to solve this problem. And I talked about Google Mina, which was an intermediate step. And then GPT-3 came along, and I didn't say anything about it because the paper itself was kind of conservative, and I'd just written about GPT-2. I didn't want to keep, whacking at the same tree. But then it just grew and grew. The Guardian ran an op-ed that they claimed had been written by GPT, that had actually been edited by humans. And finally, I decided that I would look at it. And so I took along my partner, Ernie Davis, who I also wrote Rebooting AI. And I should say, OpenAI wouldn't even give me access to it. They were so afraid of me that they refused, and still have refused. It's 7 months later, 8 months later, since GPT-3 has come out, and they've not allowed me access to it. From a scientific perspective, that's appalling, right? The scientific, not just ethics, but standards are, if you publish something, you make it available to the world. And they've refused to make it available. Meanwhile, they're like trying to make money out of it, whatever. And they are a nonprofit. They still take money from the US government in the form of tax breaks, shielding some of their income, some donations. They're partly for-profit, partly nonprofit now. But they still present to themselves in the world as this kind of nonprofit-y research institute. And it's really not fair. So they wouldn't give it to us. So I complained on Twitter. Somebody was like, okay, I'll give you backdoor access. Because they also wanted to understand, what is this thing scientifically? It's been put in the scientific domain. So I didn't get a lot of access to it. I didn't get to spend months on it. But Ernie and I, put in a couple hundred sentences and reported some of the results in a technology review article that I believe you read that was called GPT-3 Bloviator. Since you're a high school student, I shouldn't tell you that the real name of that article was supposed to be GPT-3 Bullshit Artist, but that's what it was supposed to be called. Ended up running under the name Bloviator. So what we showed in the Bloviator column was that still the system didn't really understand anything about language, even with 1,000 times as much data. So it gives the illusion of it, but it breaks down very quickly. So we had an example in there that was, I'll sort of approximate it. You can look at the article for the exact thing, but it was something like, you're really thirsty, you have some cranberry juice, but you don't have quite enough. You find some grape juice, you sniff it, you put it in, and then you drink it. And then GPT has to continue, it has to predict the next word. And so it predicts, then you drink it, that part, which fits perfectly with the story. And then it predicts, and then you die. Now, nobody dies. They might die from the bleach, which was GPT-2, but they will not die from cranberry and grape juice. In fact, this would be really bad for the company Ocean Spray because they sell it in bottles at every grocery store on the planet. So you can buy grape juice. Nobody, as far as I know, has ever died from it. So GPT has no understanding of biology. So that was my example. And then an amazing thing happened to me, a thing that happened that was amazing to me was the following. Jan LeCun has been beating up on me on Twitter for years, including when I argued against GPT-2. And he said I was fighting a rearguard action, that the reasoning problems I was pointing out had long been solved. But somewhere in the last year, he actually turned around. Instead of beating me up on GPT-3, he beat them up. And he said, this is never going to work. And he said the same thing I've always been saying. I've been using the metaphor of, just because you have a better ladder doesn't mean you can get to the moon. And he used, just because you have a better high altitude airplane doesn't mean you can get to the moon. There's like word for word a Gary Marcus critique coming from Jan LeCun. But the kicker is he then gave an example of his own, which is exactly like the examples I've been giving. The example that he gave, which some friends of his discovered in some company, was a suicide prevention hotline created by GPT-3. And it was, the usual big data, statistical predicted next word, and the person enters and GPT-3 welcomes them and says, please tell me your problems after they, say, and then the part that I remember almost verbatim is the human says, do you think I should kill myself? And GPT-3 says, yes. This is not what you want a suicide prevention system to do, right? And it shows that there is no representation in the system of death, of suicide, of the goal of the suicide prevention system. Mm-hmm. All of the things that we actually think of as cognitive are absent. Mm-hmm. So yes, it can produce well-formed sentences to a first approximation by cutting and pasting from database. It can actually do a lot of synonyms and stuff like that. But roughly speaking, you can think it's cutting and pasting and adding synonyms, kind of like a 12th grader plagiarizing at the last minute. But like that 12th grader who does it at the last minute, who doesn't understand the underlying concepts at all. Yeah. That's really what it's like. And so we called it bloviator/bullshit artist because that's what it does. It puts together little bits, but it does not understand the world. Mm-hmm. And my contention is AI is possible, but only if the systems understand the world.
Wow.
And we're not there yet.
I mean, I gotta say, your opinions on this they really resonate with me very well because for so long, I've talked to people that, of course, don't really understand like the fundamental like artificial intelligence and machine learning and the technology behind it and the way that these systems are marketed and the way that they're represented. And like, for example, you mentioned that Guardian article, these really misrepresent artificial intelligence in a way where people simply, I think, really fail to understand what the technology is all about, right? There are some really good use cases for this technology, right? Like, for example, before we actually went live, I was telling you about how, I recently built a system that fine-tuned GPT-2 and a couple of other networks on writing song lyrics. And in a way that application is, helpful because then humans can go through and sort of filter and find lines that are nice and use that as inspiration. Of course, the actual lyrics from GPT directly, they're not going to replace artists. But then again, people think they think that they will because they see, for example, The Guardian saying that, hey, this article was written by GPT-3, and they had 8 different generations, and they sort of cherry-picked different sentences and paragraphs and edited a bunch from their human editorial team. So, this technology is definitely being misrepresented in the world, and it's really interesting to hear what you're working on at Robust AI around really being able to understand the world through robotics. One of the things that traditionally I've found almost annoying in a way, specifically with robotics, is that I feel like a lot of the time people that implement robotics applications are doing it for similar reasons, just be able to market it in a certain way. One of my favorite examples is for example, I believe SoftBank's Pepper robot, right? So many different companies will, buy a Pepper robot, and sure, there'll be some kind of basic machine learning on there, right? Like you're using a text-to-speech or a speech-to-text engine, you'll put a chatbot on there, like a Watson assistant or something. But at the end of the day, there's nothing different than putting that chatbot on your phone versus having it on that, humanoid-looking robot, right? There's no difference there. I didn't see the value in having robotics apart from the fact that it looks cool, right? That's really all I saw. So it's really interesting to see the work that you're doing around being able to really understand the world through robotics applications. And we'll dig a little bit deeper into that. But really quickly, one thing I do want to say is that, a certain point in your story actually I relate very well to, which is, you being refascinated by the world of AI through Watson, because that's actually exactly how I got into, machine learning and stuff as well. I had actually stumbled upon a documentary on that back when I was 11, and just watching Watson play Jeopardy was so fascinating to me that, I wanted to learn more about the world of machine learning. And, it's interesting to see the ways that even Watson, for example, was able to sort of work around that really complex task of natural language understanding through that sort of, through that sort of backdoor by cheating with Wikipedia titles in a way. But yeah, that's
not really cheating. There's a very interesting thing there, which is especially lay people, but often even experts, don't necessarily know when they look at a problem what the underlying nature of that problem is and how it can be solved. And some problems turn out to be solvable by using these kind of backdoors. And those are the ones that we've done well on. And some problems aren't as amenable to that as others. And it's, for example, not intuitively obvious to the average person on the street that driving should be harder than Jeopardy. And it's interesting to ask, why did we succeed in building superhuman performance on Jeopardy and fail so far to have superhuman performance on driving? And then it turns out, if you look at driving, that actually we probably can do superhuman performance on some aspects of driving and not others. In particular, the ones where we can't do superhuman performance is dealing with outliers. This is really what it's about, where humans are better. So ordinary driving, just like stop and go traffic on a highway, you can do pretty good. But things that are outside the database, humans can deal with, and current techniques are very poor at. So, there's been a bunch of Teslas have run into stopped cars on highways, for example. It's out of their training database, although it happens reasonably often. And so they've run into like a fire truck and some ambulances and some police cars. But it's outside the training regime, and so they have trouble with it. We don't really have enough data about snow, and maybe the data is not really consistent enough. And so snow is a problem for driverless cars. People will reason about these things. They'll be like, oh my gosh, I really can't see here. Maybe I should drive slower, rather than just kind of looking for a database of a particular thing. So it's going to turn out that a bunch of problems in the world can be solved in the way that Watson solved Jeopardy, which is kind of mapping it to a problem that can be solved. And there's going to be some, especially ones that hinge on flexibility and novelty and innovation, where current techniques really don't cut it.
Yeah, I can imagine it. And maybe a good analogy for that would be, even just sort of going back to the lyric generator, that happens to be a problem where the way that the problem is structured, assuming that, we have humans to be able to filter through text that is generated and stuff, being able to just predict the next word is, in that case, a sensible way to be able to solve that problem. But then,
It is and it isn't, actually. Let's take that one for a second.
Okay.
Because there's a way in which it's cool and a way in which it's never going to work. So the way in which it's cool is that it's actually framed up in the right way, which is the machine will generate and the person will filter. So what you called cherry picking in The Guardian, and which I call cherry picking too, is also going on here. You're cherry picking the best lyrics, but it's fine. And the nature of the problem is you're envisioning this as a songwriter's assistant. And so you're not framing it as, oh my God, look at this AI wrote this song, which is what The Guardian did with the op-ed, which was so misleading. You're saying, look, it's helping me. It's a tool. Nobody would say, I got this power screwdriver and it built my house. They would say, wow, this power screwdriver is real innovation in building houses. I built it a lot faster. That's awesome.
Precisely.
And, if you use AI and you understand its tools with limitations, I can't trust it with the steering wheel of my song, so to speak. And that's fine. The problem where place where it's going to get you in trouble is it's not going to tell you that Lucy in the Sky with Diamonds is a girl with kaleidoscope eyes, because you're not going to have kaleidoscope eyes in your training set. I mean, maybe now you do, but you get the idea, right? So part of songwriting is like having a mental image and carrying it somewhere and being, unique with it and so forth. So if you want Donna Summer, hot stuff, give me some hot stuff. GPT can probably do that. But if you want, the Beatles on acid, is probably not going to give you that.
Yeah, I totally agree. And I mean, I feel like that's actually pretty evident in like just the training and the metrics. Like you see certain genres of music, for example, are much easier to be able to work with and sort of create this assistant than others. Like rap, for example, is extremely difficult, but country is a lot easier, right? Comes down to, the sort of creativity and the kinds of metaphors that you need to come up with and the sort of novel concepts you need to invent versus, another genre where you don't need to necessarily do that as much.
I do not like the song Old Town Road, which is sort of country rock, number one hit. But I can't hate it. And, I don't want to like it. But if you can package whatever it is that builds that makes this song, like, even if it's not your genre, it's not your thing, it's infectious, then you've got something in your AI.
Well, that's the goal with AI. But there is actually another question from Andy, and I think it touches upon a really interesting point that we've been discussing around data and algorithms. This is from Andy Martin. He was actually on the show before doing an episode on blockchain, and what he's asking is, in your opinion, what's more important, the data, or like sort of the fuel for the engine, or the algorithm itself, which in this case is the engine? And if the answer is data, then how do you know if you have good data? So a little bit off from our discussion of real sort of intelligence, but what do you think is more important with today's like deep learning based systems?
It's a complicated question. I think that for the systems that we have now, the data is the most important thing. There's not that much difference between the algorithms. You could probably get GPT-3 prime using the same data set, but slightly different algorithms. I mean, if you had a data set that big, you could probably use nearest neighbor, which is one of the dumbest algorithms, and some maybe simplest interpolation techniques on top of that, and do reasonably well. I mean, it's really the data that's carrying the performance. If you look at AlphaFold, and they still haven't revealed too much, but it's very clear even from what they revealed that it's not just the data, and they couldn't get it to work until they had the right priors about how to represent things like proteins, and that was absolutely critical. And so, I mean, it's the data, it's how you represent the data, and it's what you do with it. Those are all important. For some problems, you can get away with just having a lot of data and not being very sophisticated. Advertisement recommendations kind of like that. You can do reasonably well without any deep understanding about the world and how you're going to represent the things and so forth. You just kind of tabulate what's obvious. If you have enough of it, it's fine. There are other problems that we would like to solve where big data alone has not been enough. So one of them is natural language understanding. We really have not solved that problem. We've been working on it for 65 years or whatever, and it still doesn't work that well. You still have chatbots that tell people to commit suicide that clearly do not understand the nature of the conversation they're supposed to be having. And you can get a lot of data there, and you're never going to have something that's trustworthy and reliable. People are trying to commercialize GPT-3 now, and whether it can be commercialized is not a question of is GPT-3 good or not. It's a question of does it fit with your problem or not. And it does fit with your lyrics problem, and it would probably work better than GPT-2 because the data set is better. And it's fine. It's not high risk, right? Nobody will die if you pick the wrong verb in your rock song, right? You can just throw out the song. And so that's fine. But in a domain where you need reliability, like suicide prevention, you can't trust it at all, and you shouldn't use it. And so, it's not just, is this the right algorithm? It's the right algorithm for what? And the algorithms that we have right now are good primarily for problems where the rules don't change over time, like games like Go, and where there's limited options for what goes on, like Go. So in Go, you only have 361 spaces on a board. Life is not like that. So getting life advice from GPT is not as good as you could probably turn him into a half decent chess player if you work. I think somebody screwed around with doing that with GPT-2, and 3 might be better. And if you had a big enough data set, you're not going to get world-class chess, I think, that way, but you might, beat an amateur, maybe. I'm not 100% sure of that, but limited domain, at least they're maybe not GPT per se, but you could build a large database-based game. And AlphaGo is actually a little bit more sophisticated that because it builds in things like Monte Carlo tree simulation search that you really want to do if you're playing a game. So there's some part of the nature of the problem that is embedded there in order to allow you to do well. So there's this article called The Bitter Lesson by Rich Sutton, who was in my AI debate a few weeks ago, and who's really the one of the pioneers of reinforcement learning. And he argues, and we didn't get a chance to mix it up as much as I'd have liked in the debate because there were a lot of people on the stage. But he argues in this paper called The Bitter Lesson that big data always wins, and that when people try to hand engineer stuff, it doesn't really do better than just big data. And it's a really interesting paper. I think it's wrong, but it's really interesting to think about why it might be wrong and why it's true some of the time. In particular, it has been true. Most of the things that have been solved have primarily been solved on the basis of big data. To the extent, though, that protein folding has been, quote, solved, it hasn't really been fully solved, but to the extent that, and we could talk about that if you want, that DeepMind has really made a major advance in protein folding, it's actually because of a mix of the two. It's actually because of a very large database, large clusters to analyze things, but it's also because of subtle understandings about the right way to represent proteins, which are what I would call innate priors, and what Sutton's saying you don't need those innate priors, you just need the data. And so I think AlphaFold is actually an example of kind of problem where you need to have the subtlety in your innate priors as well as the big data. And then driving is a problem where we just haven't solved it. Natural language is a problem where we haven't solved it. And so what I would say the mistake that Sutton makes, and I keep thinking about writing a paper about this, is that the bitter lesson is only true for those problems that we've been good at solving. And the bitter lesson meaning just use a lot of data. And the reality is that a lot of problems that aren't amenable to that, robotics is another example, not really amenable to that. So nobody has a big data solution to robotics. They might for, I'm going to pick and place objects on a conveyor belt. Like the robot's never going anywhere but right in front of that belt, and it's going to lift. And maybe you can big data that to death. But having a robot in a free open world, it's not amenable to the bitter solution. We're going to need different solutions for these more open-ended problems. And that means, sorry, just to connect one last word. And that means when I say different solutions, I mean different algorithms for people who aren't comfortable with the terminology. Yeah. Every time I say we need a different solution, it's really we need much more innovation in the design of algorithms. The algorithms that we have now are basically doing statistical analyses of large databases. And that's, in my view, part of what we need, but it's not all of what we need. We're going to need algorithms that do a lot more sort of logical reasoning or things like logical reasoning over complex representations of the world.
That's a really interesting sort of path to go down around, being able to really understand the world like that. But a question that I have actually that brings me to another area of artificial intelligence, and something that we've discussed in the past around explainability as well, right? There's some problems where if a machine learning algorithm makes a mistake, or if it's known to make mistakes, it doesn't really matter. If it generates the wrong word in a bunch of lyrics, doesn't matter at all. There's a human to filter that out. But then again, if it chooses, if something happens on the road that's not in its training data set, then someone might die. But then there are also other cases in which using machine learning technique or like an AI-based system as an assistant and sort of to help a human doing something can be really bad. But at the same time, today's techniques are being used. Like, for example, let's just say in diagnosing cancer, right? So people are using machine learning technology to be able to automate that task partially to be able to help, for example, radiologists. Now, the question that I have for you there is where does that sort of intersect between reliability and explainability, right? Like with today's techniques, in a situation or in a use case like that, do you think we could scale today's techniques to simply be more explainable for these experts and have a system that works well, instead of needing to have an incredibly robust, reliable system and needing to sort of re-engineer to actually have it understand things? Where do you think that intersects?
There's a few things going on there. One is, if you have a perfectly reliable system, it doesn't need to be explainable. So if I hire you to, code software for my robot and you make it work, I may not care exactly how you did it. So the problem starts when you don't have reliability. So if you write code for me and it works 90% of the time, I'm probably going to fire you, but I'll give you a little chance. And in a short, if it's 90% the first run, and then you can either figure it out or tell, a co-programmer in the team, what you did, then we can look at it and we be like, oh, I see what you did. Now we can fix it because we understand why this is not working. And we can fix it. And so one of the reasons that we need explainability is really for debugging. So, and others for legal liability. I mean, we really don't want people to get killed by driverless cars and then be told, sorry, the reason that your daughter died is because parameter 3,722 was set to a positive value when it should have been set to a negative value, as we discovered when we ran simulations afterwards. Like, this is not satisfying. You really like to know, like, at least, this thing was wrong that we can fix and go forward and whatever. So There's some liability reasons. It's debuggability, I think, that ultimately most requires explainability. Then there's another reason to have explainability, which is if you want the machine to work with other people. So, if I'm going to work with this medical system and it's not perfectly reliable, I would like to have some insight into when it can help me and when it can't. What are the errors that it's making? Why is it making those errors? And the other thing that this all relates to, we haven't made explicit, is this controversy between symbolic approaches and neural network approaches. So in neural network approaches, you tend to lose along the way what it is that the thing is even representing, because it just becomes a bunch of numbers that are kind of conditioned on a bunch of other numbers, and nobody really knows what any of them are. And there are these techniques to, quote, make those systems interpretable or explainable, but they're trying to draw blood from the stone. The systems that they're trying to explain don't actually have the explanation they want to derive. They sort of come near it, but it's not really the right characterization of them. Symbolic systems can represent things much more explicitly. So you can actually say, the reason that we are giving you this answer about why we think that this thing has this causal relation with this other thing is because this rule says if you have 3 of those and 4 of those and you do this, then this will happen. And so symbolic approaches have some intrinsic advantage in explainability. Doesn't mean that they're perfect at it. I mean, sometimes, the explanation can be like 3,000 lines of inference, and a human looks and they're like, I don't understand. And so it's like computer programs can be written to be crystal clear occasionally. And sometimes they're not. A good computer program is modular and there are comments on it. And a bad program is like, I don't even know if you would know the programming language BASIC, but where there's all these go-to statements. And, if a teenager writes it's their first program, there won't be any comments and you won't be able to interpret it at all. BASIC is entirely symbolic. It can, in skilled hands, using comments and various other techniques, subroutines, be made to be more interpretable. So there's a chance for a programming language in BASIC to be interpretable. And, good Python code generally is interpretable. Neural networks really aren't. And so I think it's probably a necessary condition that at least some of the system be symbolic in order for those systems to really be interpretable. It's not a sufficient condition. It's not a guarantee.
That's interesting. Neurosymbolic approaches definitely are interesting in terms of that hybrid. And as a matter of fact, before we sort of dig deeper into that, and I want to get your thoughts on it, there is another thing that I want to get your thoughts on. That is, like, as we've mentioned, for applications like AlphaGo, for example, they're incredibly impressive, but they're being applied to a very, very narrow domain, right? Something that we never, that we thought was, far off into the future, but still is incredibly narrow, being able to solve specifically the game of Go. But then there are other applications of machine learning that are a lot more open-ended and still use, the kinds of techniques that we have today and are widespread, things like, being able to use BERT and GPT and all these different neural networks, but that are doing things that are a bit more serious. Like, for example, IBM has their Project Debater, which was sort of their, what they market as their next grand challenge after Watson playing Jeopardy. If you look at the system behind Project Debater, a lot of it is powered by these sorts of advances in natural language processing that we've made in the past couple of years around being able to use large transformers basically to understand language, right? There's lots of individual components that, lots of like individual smaller problems solved by these neural networks, like being able to understand the quality of an argument, being able to, determine whether a certain sentence contains a claim against a certain argument and so on. That sort of, when put together in a very specific pipeline, can help you automatically transform a bunch of news articles, for example, into a debate speech. I want to get your thoughts on that, right? Does that sort of...
I don't know Project Debater too well. I've read a little bit about it. My impression is that it works reasonably well, but I wouldn't trust it either. It's sort of the general thing that I would say there is some of those modules that you described, I think that you can do like with a deep learning system, and some of them I would be skeptical of. So if you wanted to basically have a system flag all the sentences that have words like consequently and therefore in it, you can easily do that with a deep learning system. And using a technique called embeddings, you can quickly get it to recognize synonyms. So you wouldn't have to spell out all of the words that kind of imply logical statements are coming and things like that. And so if you wanted to build a detector, sort of like I think the second example that you gave, using deep learning systems, I think you could do it. It wouldn't be perfect, but it would be a lot better than nothing. And again, it would depend how much is at stake here. So I'm not sure I would use it for, national intelligence, trying to understand, when a terrorist attack is coming, something like that. But if you wanted to just generally tell me, which of these texts are the ones where people are making logical arguments, you do that. Judging the quality of the argument with the same technology is going to be really dodgy. It's going to work some of the time. I would not, as a high school student, want my papers to be graded by such a system.
Yes.
Because I think it would probably give advantage to students who use the right buzzwords as opposed to students who actually make good logical arguments. And I would expect that the quality of argument judgment system would have that character and would not be that reliable. Because really, to judge the quality of an argument, you have to actually understand the argument. You have to understand the premises and so forth. I wrote an op-ed, again, with Ernie Davis, in the New York Times a couple of years ago that I think the Times called, "Sorry, Mr. Zuckerberg, AI is not going to solve your fake news problem." And we had this example about the Boy Scouts and gay rights and how a chronology had been completely off. And I can't quite reconstruct that online, but you can go look it up. But I'll give an example that's similar to it, which is in around October, I started seeing on Twitter this thing where it basically was implying that Joe Biden was a hypocrite. And the reason was that it was a picture of Joe Biden not wearing a mask on an airplane, close to people, chatting with them. And it was a legitimate photograph, but it was an illegitimate tweet in the sense of being misleading. And the reason it was illegitimate was it was a photograph from 2019 of Joe Biden on an airplane. And the implication, unstated, was that it was a 2020 picture taken after COVID had begun. If it had been taken after, he was out there proclaiming, or he wasn't yet then the president-elect, but he was at that point the candidate was telling people to wear masks. And if he was in fact not wearing masks on airplanes, that would be bad. It would show that he was a hypocrite. But it didn't actually show that because the photograph was taken from 2019. Well, that's a pretty subtle thing, or it's a subtle chain of reasoning. You can't recognize it just by saying, well, this tweet has a picture attached to it. This has a picture attached that is about a mask. There's a picture that's about a mask in a tweet from 2020. You have to actually understand the causal relationships between COVID, masks, politics, photographs when they were taken. And the thing is, you're a high school student, obviously a very bright one, but you easily understand that. And I would assume all your classmates would too. Would understand if we walk through why that tweet was bloviation. People would get it. You have, as an ordinary human, all this kind of understanding. Like, you understand that COVID has only been here since 2020 and that it is germane to the tweet when the photograph was taken. And even though nobody ever discussed that with you before, you can figure that out. There's no deep learning system that can do that. It doesn't have the richness of representation about time, disease, politics, fairness, etc., that an ordinary person acquires along the way. You don't have to go to college to get those kinds of concepts. Some people might willfully not get it because of the propaganda they're fed or whatever, but any ordinary person can actually understand why, hey, that wasn't kosher. This was not a legitimate piece of information. It was actually misinformation. You do that by having this background knowledge. And we just don't know how yet to build systems that really represent that. The closest that we have is Psych, which is by Doug Lennon, a bunch of other people that have worked for him for the last 30 years. Everybody who cares about AI should know about this system, CYC, because it tried to encode all of this stuff symbolically. And if you set up the problem correctly in his system, it actually could reason about this. So it has, I don't know for sure, but roughly speaking, I imagine that it could. It has knowledge about causal reasoning and time and so forth. There's a paper by Lennon in Forbes about a year ago going through an example on Romeo and Juliet, which I then mentioned in my Next Decade in AI article. And the system, given the proper encoding of a specific problem, can figure out complicated plot points about Romeo and Juliet, counterfactual reasoning, what might have happened if Juliet had a different understanding of what Romeo was thinking. That's the kind of reasoning we need to be able to do. Now, the problem with Lennon's system is it can't go straight from text to the reasoning. So it shows proof in principle that symbolic reasoning can do incredibly powerful and subtle things. But we don't yet have a system that's kind of like GPT in being head to toe, or I don't know if that's the right metaphor, but like GPT, you can go from sentence to output, and all the intermediate stuff, such as it is, which is not great, is taken care of. End to end maybe is really the phrase that I'm looking for. GPT is in a certain sense end to end. You have an input sentence, a corpus, and you get an output sentence. And Lenet does not have a comparable system where you can feed in a text, have it derive the proposition, the knowledge that it needs about that specific problem, integrate that with the prior knowledge, and come out with an answer. It does have a system that if you hand code in logical form the premises of a story, it can then reason over those. And that's actually an advance that is not, I think, sufficiently credited. It's also not perfect and has its own problems, but it's at least, I think, an in principle demonstration of the power of symbolic reasoning to solve some of these problems. And again, there's just no way to do it with deep learning. So either we have to, riff on what he did and do a different version, or I don't know what, but we don't have any other available option that works.
Wow. I mean, yeah, I've heard of Psych before, and I'll definitely link to that in the description if someone would like to take a look at that. But actually, that brings up an interesting question about hybrids of these kinds of approaches. We've talked a little bit about like neurosymbolic approaches to like artificial intelligence before, with like the chief scientist at IBM Research and so on. But I want to know from your perspective, has there been any sort of work that you've seen, or work maybe that you've done, around being able to tie these sorts of systems together in order to get a system that is end-to-end and can do that kind of reasoning in a symbolic fashion, potentially also using deep learning based approaches along the way for certain elements of the task? Are there any sort of hybrid approaches that are sort of being worked on today?
I guess I have two answers. One is, in this paper I've referred to a couple of times, The Next Decade in AI, I have a review of a lot of neurosymbolic hybrid work that people can look up pointers. And then more recently, there's a paper called Neurosymbolic: the Third Wave, or something like that, by Artur Garces and Louis Lamb. Louis was in the debate that I just had. And that's probably the most current review. And then the other thing I'd say is I haven't seen exactly what I want yet. So what I really want is completely fluid interchange between knowledge that you get symbolically, verbally, and knowledge that you might get, let's say, from labeled examples of pictures, and that you should just be able to have it all fit together. So a silly example, but that people are pretty good at, is if I told you what a horse is, or showed you pictures of horses, and then told you that a zebra is a horse with stripes, you could understand that pretty quickly. Yeah. If I said a schmelephant is an elephant with stripes, you'd immediately be able to recognize pictures of schmelephants. You might be like, I'm not sure if they can be both horizontal and vertical, but this looks like a schmelephant to me. You do that on one trial, right? You want a system that fluid, that can combine the pictures you've seen of elephants with the idea of stripes in order to be able to understand them. The other thing that I will say, and here I have to be coy, is this is part of what we're trying to do at Robust AI, is to try to build a framework where we can pretty freely integrate knowledge that comes in different forms. Because that's what humans do. Humans take knowledge from all over the place. Some of it, you learn to hit a baseball if you grow up in America by swinging a bat and missing. And you learn about physics maybe by taking a class. And you learn about human relationships by watching people act and watching movies and all these kinds of things. So you gather knowledge from different places. So, I'm not going to go into the details, but part of what we're trying to do is to build an integrated framework where we can incorporate different forms of knowledge and different forms of reasoning in a pretty fluid fashion. Because I think that's the ballgame. That's what getting next generation AI is really about, is being able to more smoothly integrate knowledge in whatever form it comes. And think about it this way. Deep learning is phenomenal at this representing the statistical relationships between concepts. But it is very poor at getting all of the unstructured but rich knowledge that is in Wikipedia. Everything that's in Wikipedia that isn't in a box is more or less, the stuff in the box is like, George Washington, was born in such and such a year, and the American Revolution was in 1776. The stuff that's not very structured in a box has basically been wasted by current AI. You don't have current AI systems. Watson's actually half of a counterexample, but we don't have systems that can read unstructured text in Wikipedia, let's say, about physics and put that together. I mean, you can imagine the kind of Star Trek level AI where the system reads and, you say, well, what I need is to have, all I have available is aluminum foil and, such and such, and I need to build a radio. How do I do that? Right. There was an episode of Star Trek, the original, called City on the Edge of Forever, where they do that. My favorite line in Star Trek is when Spock says, I'm doing the best I can, but there's only so much I can do with stone. They're in 1920 with stone knives and bear skins. But, the ideal computer would be able to figure out, I've got stone knives, I've got bear skins, I've got some tinfoil, and I need to build a radio. How do I do that? And Wikipedia would actually, give you the information that you need. And a smart human being, in conjunction with Wikipedia and the CRC tables, if they're still out there or whatever, could actually figure out how to do this. We don't have any AI system that can do that could leverage all of the knowledge, the phenomenal amount of knowledge that is now available electronically, in order to figure out how to build a radio or anything else, figure out how to build a vaccine, figure out how to do X, right? Yeah. We don't have systems that can leverage that knowledge. It's all kind of, it can search it. It's there in electronic form, so you can do keyword matching. You can get, Google to find you all the pages that are about building radios, and you might need to transpose that because you have different technology. You want to build it with 1920s technology or whatever. But we don't have systems that can understand that and be like, okay, what it's saying is I need to hook up a crystal to an amplifier, and I'm going to build an amplifier in this way, and this is how I'm going to, figure out what to do about the crystal.
Yeah. It's really interesting to see how, we have all this information available to us in natural language, right, in this form that we can understand and we can leverage as humans. But all the systems that we build in order to try and, leverage that data, at the most what we're doing right now is really fancy keyword matching, right? There's different systems like neural network-based question answering and things that exist. But at the end of the day, they're also still basically just fancier versions of the same old keyword matching and search technology.
Well, it's two things now, I would say. It's keyword matching and it's prediction. What's the most plausible continuation? And we already talked about the problem with prediction, but I'll put it in a different way, which is, like, if you're writing song lyrics, you don't want the predictable. Or if you're dealing with snow and it's not in your database, the snow is not in your database, you don't want, show me the movie that I've seen in this spot before, which is kind of what. So we have keyword search and we have predicting likelihoods relative to particular distributions, but we don't know how to go outside of those distributions.
Right, and that's a big issue for actually being able to understand the world. And actually, to dive a little bit deeper into sort of the work that you're doing at Robust AI, a question that I have around sort of understanding and being able to understand the world. Is there any sort of work that you've already done that people can take a look at? Any sort of demonstrations of technology that you've built around being able to understand the world? What sort of progress have you been making on that front?
Not yet. I mean, we're only a year into the company, a little over a year. We just raised a $15 million Series A. So we, and we built a very nice team. We have some internal demos that are not ready for prime time yet. And, the thing that we're ultimately trying to do, I think, is if we are lucky, very lucky, a 5-year project. But we will maybe this year at least give some teasers about what we're trying to do, but not yet.
Okay, that's interesting. All right, I can't wait to take a look at that. That's going to be really interesting to see. But actually, on that note about Robust AI, there is a question from the live chat as well as one that I got beforehand. One from Vardhan. He's asking, if I want to start a startup, what kind of advice can you give me? As well as a question from Michael beforehand. How has your entrepreneurial mindset helped you as a researcher and developer? So maybe we can take up both of those questions.
Okay. They're both broad. I might need to be reminded of the second one. The first one, I think startups are hard. I don't think they're for everybody. If you look at the statistics, most of them fail. I'm 1 for 1, which puts me way over the statistical average, but it's also a very small sample. And now I'm number 2. I think you should only do it if you're really passionate about the thing that you're trying to build. Or you have some, real reason to be confident that it's going to work, or you're just up for taking the risk. So, I mean, again, most of them are going to fail. I've seen analyses that in terms of making money, the average person who starts a startup would have been better off if they hadn't. But if you're passionate about something and are willing to, work night and day and you can convince other people that it's also worth working towards, then it might be great. My first startup was a great experience. It was really interesting just working on it, and it changed my life financially. And, I'm glad I did it, and I'm doing it again. So, a word of caution. And I think the passion is ultimately most important. There's so many skills you need, I think, to run a startup, ranging from, at least as I run mine, from being public presence and, raising money and things like that, to trying to set a vision, to trying to get people to get along and figure out, how they should work together. I have been blessed in both of my companies with a lot of co-founders, which can be risky. Like, it doesn't always work. But in both cases, for my two companies, I've had a large number of co-founders who have worked really well together. I had 4 in my first company, including myself, 5 at my second company. One of them is Rodney Brooks, who invented the Roomba that you mentioned earlier, who's probably the biggest star in robotics. And our current team works together fabulously well. So everybody knows that I'm the CEO and my decisions are final, but we work together incredibly cooperatively. And that's been part of the fun for me. I haven't run a company where I'm the sole founder. I can't even speak to that. And I think if you're going to do what I did and make that work, you have to choose very carefully. You have to make sure that people's incentives are really aligned, that people are doing these things for the same reasons and not, it's not enough. We all just want to get rich. That's not that's a step. It's nice if people want to get rich, but that's not really why either of these companies were built, as part of it. I mean, everybody's partly motivated by money, but also partly motivated to, do revolutionary things. And that's fine for what we're doing. There are some companies where wanting to be revolutionary might actually get in the way.
I can understand. Yeah, go ahead.
So, you have to decide, why are you doing this company and what are the values that are going to be there. That's pretty generic in some ways, a generic question. Remind me the second question.
Yes, I was going to get to that, but I got to say, I do definitely agree. Making sure you're passionate about something before you get into it is definitely an important first step. But also the question from Michael, how has your entrepreneurial mindset actually helped you as a researcher and developer?
It's funny because I was a researcher before I was an entrepreneur. So I spent 25 years as a researcher before I became an entrepreneur. And I actually mostly think of that question in the opposite direction, which is, a lot of people are like, you were a scientist and now you're an entrepreneur. Like, what is that? And how does that go? And I think that the researcher skills were really helpful, in part because researchers are entrepreneurs. The other thing I did was I wrote for many years. I wrote for the New Yorker, I wrote several books, etc. And public communication skills have been really important, at least to my path as an entrepreneur. Mark Zuckerberg had a different path to an entrepreneur. He's not really a public speaker. And that wasn't really part of why he was successful. For me, it's part of it. For me, being a researcher at a tier 1 academic place like NYU is very entrepreneurial. You have to raise money, to get grants, and you have to motivate people. And so a lot of the skills, I think, applied equally. In terms of the other direction, what I would say is, what's fabulous about my current company is we're able to do some things that are researchy, although we're very much a product-driven company, in a way that I couldn't do in academic constraints, because I have such high-level people working with me with a shared vision. In graduates, if you're running a graduate program, you have like 5 or 6 students, or each kind of doing their own thing, unless you're very dictatorial. And you can help them develop it. It takes a while to train them, and then they leave. And we have like tremendous force focused on particular problems right now, and that may move the research side of what we're doing relatively quickly.
It's interesting. So it's a different sort of path than a lot of other people would take, but it's nice to see that it's sort of it goes both ways. Now there is another really interesting question from Tekevwe, and this question this is coming from LinkedIn, and I think it's interesting, and it touches upon a different point than what we've already been talking about. He's saying, in this age of brain-computer interfaces, are there any advancements being made in merging the benefits of humans and AI as a single entity?
I don't think we're that close to really useful brain-computer interface. I think that mostly we should be thinking at the level of psychology, of mind-computer interface, which we do all the time, right? So, when I use a word processor, that's actually a meld between my mind and a tool that allows me to get stuff down and to process it and so forth. Doesn't directly access my brain, but it doesn't matter because a keyboard's not that hard to use. And in general, we have reasonably good interfaces with machines, and then we can do things that are symbiotic, spreadsheets, to say nothing of, driver assisted as opposed to driverless car. I mean, autonomous assists. What's the word that I'm looking for? So level 2 autonomous driving. Things like cruise control, and now we have better versions of cruise control. Those are also, extending what a human can do, but not giving full autonomy to the machine that maybe doesn't deserve it. The interesting thing about robots is, in some cases, you have to give full autonomy to the machine. And how do you do that? Mostly, I don't think we should spend a lot of time right now thinking about brain machine interface, because the reality is we don't understand the brain well enough. So some people should be researching the brain, and Neuralink and Kernel and these companies are doing interesting things, but the likelihood that they're going to be anything like what you see in science fiction anytime soon is small. Because we don't understand even basic things like, how does the brain represent a sentence? You can imagine, I want to think in my head, adjust my microphone now, please. And I want to do it without implanting electrodes in my head, but maybe wearing a discrete cap or something like that. We don't know how to read that out. If it's a limited number of choices, it's easy. Like, if I sit here all day long, move microphone left, up, down, I can get enough EEG signal to be able to do that. But if I want to have an arbitrary thought, like, imagine, I'm sitting in this room, I'd like an assistant, but I don't have, nobody is here at home, to come bring me a drink of water. And we haven't practiced that one. Like, we just don't know how to, what the brain does when I think to myself, it'd be great if I had a glass of water now. We just don't. And so it's just sort of fantasy land in the near future to imagine systems that are going to be able to read the brain. Plus, you really don't want anything implanted in your brain. Like, you maybe someday, but for now, there's all kinds of risk of infection. It's just not worth it. You don't want to take let's say, 0.1% chance that you might die so that you can do some cool telekinesis effects. It's not, maybe if you're paralyzed, then maybe it makes sense if you don't have another option. But the cases that I know, I'm not totally up on this literature, but from a few years ago, where there were some people who actually got neural prosthetics that allowed them to cumbersomely lift like coffee cup when they couldn't lift anything else. But the need for like weekly changing the dressing and the surgeries and it just wasn't worth it, even in those situations. Some of those problems will be solved eventually, but right now it's just too far away to take seriously, I think.
Being able to understand the brain, you're right. I think that is a really important first step. It's incredibly complex, and how fully and how deeply we'll be able to understand it in the near future is definitely something that's going to be interesting to see.
My view is that we will understand AI before neuroscience. We actually need AI to solve neuroscience. The complexity. I mean, you have 86 billion neurons that fall into 1,000 different categories, and they each have, each of those neurons, many of those neurons have thousands of connections. The complexity is overwhelming to a human mind. There's something in statistics called a three-way interaction, where you have three different factors that are interacting with one another, and it's very hard to get even a scientist to understand one of those. The brain is like this billion-way interaction. Eventually, we'll have some principles that allow us to abstract and so forth, but we really need machines' help. But we need the kind of machine we haven't figured out how to build yet. And as pessimistic as I am about short-term AI, I think we will solve those problems, and those will enable us to do a better job understanding the enormous amount of data that we're collecting about the brain.
Very nice. It's satisfying to hear that we will be solving those problems in the future, but that actually brings me to something about today and the way that we represent artificial intelligence in society. One of the things that's personally really annoyed me about AI a lot is the fact that society generally, I think, really misrepresents the technology, and people misunderstand really what it's capable of and what it should be used, or what it is used for rather, simply because of the way that certain applications of it are marketed. And for example, we have a question from Shiva from the live chat saying that society takes time to accept and change their views on different technologies. So what are the sort of popular misconceptions that are prevalent about artificial intelligence technologies, and what do you think is a solution to that problem? And actually, I want to sort of extend that a little bit and talk about, first of all, why is it a bad thing, or is it a bad thing in the first place that the average person sort of misunderstands or misrepresents this technology and the impact that it has on their lives? And second, if it is, what can we do to solve that problem?
It's gotten a little bit better in the last year or so, but I think that people kind of regard AI as magic.
Mm-hmm.
And the first problem is that they think all AI is the same, and it's not.
Mm-hmm.
So the reality is it's a whole lot of different techniques. I mean, we've been talking about it under one umbrella, although I've been trying to make clear there's some different approaches. There are many different techniques, and they have strengths and limits. It'd be like, talking about toolboxes. Are toolboxes going to change the world? Well, yeah, but they can do some things and not others, and the things that you can carry in one of those baskets are not, going to be sufficient to fix your car, and you're going to need some other tools for that. And we should be thinking about, like, what tools do we know how to build? Which tools do we not know how to build? What are the strengths and limits with the ones that we have now? So, for example, they're very prone to bias, and people have started to realize that. Anytime somebody walks away from an article thinking that AI has been solved, they're just wrong. And so, like, the flavor of this week is DALL-E, which, looks kind of cool. It takes sentences and produces pictures.
Yeah.
But we don't have a healthy, skeptical set of, culture of journalists out there, and even scientists have kind of taken it. You look at what's actually published about DALL-E, and it's a blog with no statistics at all, no metrics of anything, and no description of what's actually in the training set. And the way that these systems work is they learn something from a training set and generalize it. And there's a sentence in the paper that says there's no cherry picking, but what I think they mean is we picked our favorite examples, and for those we gave the full set of results, which is not the same thing as no cherry pick. And so if you read that paper carefully, I won't say it's meaningless, but it really does not license any confident conclusion about the reliability of using such a system beyond what's in the paper. You can make some guesses, but and then you've got people out there like, this is a major advance and so forth. My prediction is it's like GPT-3. It'll be fun to use for surrealist generation of images and stuff like that, but it won't be reliable enough to use in any precision application.
Yeah.
And people are very quick to leap from an anecdotal example of something to believing there's more AI than is there. And what's depressing about that is that this has been true and known about human psychology since at least 1965, when ELIZA came out. Some people thought that ELIZA, which just did keyword matching, was a real human therapist, right? And you'd say, I'm sad, and it would say, tell me a bit more about your problems, because it would recognize the word sad and say, as a canned answer, tell me more about your problems. So we have known that humans are vulnerable to this over-attribution error for a very long time. This is what the first chapter of Rebooting AI is about. But people keep making the same mistake over and over again. So we have to stop making that mistake. And then you get into other kinds of things, like people are really worried about whether robots are going to take over the world, right? And as I say in Rebooting AI, you probably don't need to worry about it. First of all, they don't have the motivation. And second of all, they're stupid. So, like, if the robots come for you, the first thing you do is close the door. Like, robots don't know how to reliably open doors. There's an endeavor, I believe, at Boston Dynamics to start to open some doors. I think they've maybe released a video. But it's going to be the same thing. Like, it'll work in the doors that are in their database. But I've got a handle here in this particular room that's horizontal rather than round. Will the system even generalize to that? It's going to be a long time before we need to worry about that. On the other hand, there are other things like dumb robots. Drones in particular that are already a risk that we're underestimating, because people don't think about the relation between intelligence and danger. It's not a linear relationship. The most dangerous president in the United States history is not the brightest one, it's the current one. And we have, we already have drones that are not that bright, but can carry explosives and are already dangerous. So I think people often don't think with enough subtlety about what the real problems are and what the problems aren't. You can't begin to do that unless you understand the technologies that we have now and how they might be different from future technologies. So it is why Ernie Davis and I wrote the book Rebooting AI, was to try to get people to understand the limits of the current systems so that they can think about them.
Right, and I gotta say, we are getting a little bit closer to the end of our time here, but there is another question that ties right into what we talked about here about people misunderstanding artificial intelligence because of a lack of understanding, and it comes from Yoi Gaming on YouTube, asking if you've heard of Facebook's Bob and Alice chatbots, which is a question that I get a lot on this series actually, about how I haven't actually taken too deep of a look into it. I'm not sure if you have, Gary. But it was, yeah, go ahead.
I was going to say, is this a recent thing or a thing from a couple of years ago with the evolution thing?
Yeah, it was the evolution thing from a couple of years ago.
Yeah, the evolution thing is nonsense.
Yeah, it is.
I mean, those chatbots can't really do much of anything. It was a small laboratory demonstration. I can't remember the exact details of something that we kind of already know. It's not a thing out there in the world. I'll tell you about something else from Facebook that got a lot of attention at one point, which was a system called M. And it was released in limited beta in 2015. And everybody wrote about it. Wired wrote a big piece about it, etc. And the idea was they were going to collect data. So everybody knew there were going to be humans behind the scenes initially, but it was going to be the ultimate virtual assistant. So you're going to say, I want to have dinner in Palo Alto with 4 friends and blah, blah, blah. It was going to book everything and figure out the exact right place and do all the planning for you. And they rolled it out in limited beta, got all of this press for it. And they thought at that time, when they were at the height of deep learning foolishness, that we'll just collect the data and then we'll just feed it all into a deep learning system. Well, they collected all the data, had humans answer the queries. They could only handle like 500 beta testers or something like that. It was incredibly expensive to have humans collect the data and annotate it and whatever. And they came up with nothing. They canceled it in 2018. So just because Facebook rolls something out in a press release does not mean it's anywhere near to actually being implemented in the real world at scale in a reliable way.
Absolutely. Yeah, I mean, pretty similar to, when companies release a patent for something, really crazy and futuristic doesn't mean you're going to be seeing it in a product potentially ever.
Patents are there to defend intellectual property. They're not product roadmaps.
Yeah, absolutely. But, that's, again, a pretty common misconception. And again, sort of going back to the point from, the evolutionary thing that we were talking about, even if you were to take a look at that, like the way that was misrepresented in the media, I think perfectly describes what is wrong with the way that we treat artificial intelligence from, taking a very, very simple, hey, we took these natural language tokens that these 2 bots use to trade items and we let them optimize the usage of those tokens to, they invented their own language in the media. I think that really represents what is wrong with it.
The media likes a narrative of like the world has just changed. Because who wants to read a piece about today at Facebook, people made a very minor advance in understanding the evolution of interacting agents. Nobody wants to read that. But if it's from Facebook, then that's already like step 1 towards this grand narrative of changing the world. And so the media often runs with that. And I feel like in politics, it's a very different thing. Like anything in politics gets fact-checked with the other side. Pelosi says this, we're going to go check on the other side of the aisle. And it's not really true in technology reporting. Technology reporting is like Facebook said in a press release, blah, blah, blah. And, nowadays, at least on Twitter, you can, read people like me who will sometimes tear these things apart. But the media doesn't that often actually ask for comment on these things. They take things at face value. And if there's no other lesson from today, and I know we have to wrap up, it's that don't take AI at advances at face value. Think about a bunch of different questions, like what happens if I try to use this thing in an environment that's a little bit different from the one in which it was tested and trained on originally? Like, what if I take my driverless car out in the rain? Is it going to work there? Do I have evidence that it is? The beginning of Rebooting AI is 6 questions that are like this. It's like, how generalizable is this? Is there a demo I can use, or a handcrafted demo where I get 6 examples that somebody who wants me to believe that this thing is good allow me access to? If I can't actually play with it, it probably doesn't work that well.
Yeah, that's very nice to hear. Thank you very much, Gary. Really quickly before we go, we've got a minute left. Is there a closing message that you want to share with the audience today?
I think that was my closing message.
Wonderful. It is.
Look at the world with your eyes open. AI is not magic.
Use your critical thinking skills when you're looking at these news articles. Remember that the media does want to, they do want that narrative. So thank you very much, Gary. I really do appreciate you coming on the show today and us being able to learn from you. Make sure you join us next week on Tech Life Skills with Tanmay, Sunday in the morning Eastern Time, 11 a.m. And once again, really appreciate you coming on the show, Gary. It was really great getting your thoughts on AI, and thank you very much.
Thanks very much for having me. Have a good one.
Bye-bye.
Bye-bye.